Concept 2, elimination using subtraction. So elimination using subtraction is pretty much the same as elimination using addition. The only thing is, instead of looking for opposites, so we have 2x and negative 2x, so when we add them together they disappear. We're looking for the same values, okay, or the same coefficients of that variable, okay. And really what you're going to be doing is you're going to be looking at a system, okay, and then you're going to decide whether to use addition or subtraction. All right, when you have that opposite, right, I have negative x and positive x, or negative 1x and positive 1x, so I know when I add these together they're going to disappear. That makes me want to choose addition. It'll be easier. All right, subtraction, same thing, except I don't have opposites. I'm looking for the same values, okay, the same coefficient next to one of my variables. All right, I've got 2y and 2y, so that's what I'm going to go with. I'm going to use subtraction to solve this system. All right, so let's go ahead and do that. This one is nicely started for us. We kind of get to skip the first couple steps. We've already got our variables lined up vertically. We've got the same things on the same sides of the equation, and we've got our coefficients the same. So when I subtract 2y from 2y, I'm going to get 0y. Okay? When I subtract negative 4y, and then I subtract 5x, start over. When I have negative 4x and I subtract 5x, that's going to get me negative 9x. Okay? When I have 3 and I subtract negative 6, I'm going to have a negative 6 or minus negative 6, which is going to be 3 plus 6, which will give me 9. Okay? Divide by negative 9, divide by negative 9, and I get x is equal to negative 1. Okay? Same thing, plug that back into one of your original equations to solve for y. I think because my x value is negative here, I'm actually going to use this top one because I can get rid of my negatives, okay? Or at least at the start. Yeah. So I'm going to take this and go 2y minus 4 times negative 1 equals 3. Negative 4 times negative 1 is going to be 2y plus 4 equals 3. But now when I start to isolate y, I am going to go back and subtract 4 and subtract 4 and have 2y is equal to negative 1. So I'm back to a negative, but that's okay. And I divide by 2, and y is equal to negative 1/2. Okay, and there I've got my values. I've got my negative 1, negative 1/2 ordered pair as the solution to both of these equations. All right, let's look at another one. This one's not quite as nicely set up for us. So the steps you'll see are pretty much the exact same. The reason that we're looking for terms that are either opposite or the same when we're looking for elimination is sometimes when they are on different sides of the equal sign, they're going to change. Right? When I move 2x over here, it's going to become negative 2x. Or if I move this negative 2x over to the other side of the equal sign, it would become positive 2x. Okay, so doesn't really matter when you see a system, you see those two equations, and you say, okay, I've got a 2, I've got a 2. It doesn't matter if one is negative or positive, at least not at the start. Okay, because your second goal is going to be to line those terms up vertically, and that's when you're going to decide whether to use addition or subtraction. Okay, so let's do this, and let's, just because I prefer to get rid of negatives, let's move this negative over here. So we're going to add 2x, or sorry, move this x variable over here. And we're going to add 2x, and that'll give us our 5y equals 2x minus 4. Okay, and then I can bring down this other one. Doesn't matter which one is on top, so which one you're subtracting from. Generally, I like to keep my variables positive, so that's what I'll probably do. I'll take my negative y here equals 2x plus 3, and that way when I subtract this equation from this one, this will end up being positive, this variable. Okay, you don't have to do it this way, and in this case I am going to end up with negative constants. I just like to keep my variables positive. Okay, so let me make sure I got that right. Yep. All right, so it's going to be kind of messy, but that's okay. So we're going to start, we've got 5y minus y, or sorry, 5y minus a negative y. Okay, so I can write it like that. And that's going to give me 6y. Okay, 2x minus 2x, and then a negative 4 minus a positive 3. And if you want to put a negative sign with quotation or parentheses, that might help. It'll help to eliminate some of those easy errors that people sometimes make. So negative 4 minus 3 should be a negative 7. And yeah, we are going to get a messy answer because we're going to have y is equal to negative 7/6. So let's see. Do I want to mess with that? Do I want to try and... I don't think I do. I don't think I want to go back in and try and solve for it. Well, yeah, let's do it. Okay, so let's go into... yeah, let's go into this bottom one. So we've got negative y equals 2x plus 3. So negative 7/6 equals 2x plus 3. Okay, and then the negatives cancel, so we'll have 7/6 equals 2x plus 3. And let's see, at this point I'm going to multiply everything by 6. I think that's going to be my best way to get through this. So those will cancel. So I'm left with 7 is equal to 6 times 2x, or 12x, plus 6 times 3 is 18. And subtract 18. Subtract 18. I end up with 12x is equal to negative 11. Divide by 12. Divide by 12. And my final answer for the solution to this system of equations is negative 11/12 and negative 7/6. So pretty messy, and this goes back to one of those reasons why I would not use graphing as my first choice for solving systems of equations most of the time. Okay, because if I was going to graph this and try and figure out where those two lines actually cross at negative 11/12 and negative 7/6, that would be pretty difficult. I would probably not be able to look at a graph and say, yeah, that's my point. All right. So I prefer elimination or substitution. Graphing is just a nice, easy way if you've got easy lines, easy equations, or maybe ones that are already graphed or one is already graphed for you.